Okay, for section 4, now this is going to look at, instead of just trigonometry functions in general, it's going to look at it for any angle possible. Okay, this isn't necessarily on the unit circle, but you use the unit circle as a tool for a lot of this process. Okay, because the idea is we're just going to expand it. Now this works for everything where sine of theta is going to be equal, instead of just equal to y, it's going to be equal to y over r. Technically though, when it was equal to y, this formula still applied. Because what was r? 1. Okay, so it's the same formula, they just didn't show you the fact that it was all over 1, because they expect you to know that. So y over r for sine, x over r for cosine, so on and so forth. A lot of times then you're going to be given the coordinate and you just need to figure out what r is. Now the nice thing there is, because this xy coordinate represents a distance from the y-axis, a distance from the x-axis, you can actually just make a right triangle out of this stuff. So if I drop the vertical down to here, you have x and y. Well, this side is r. That's why, honestly, the r formula is just a modification of the Pythagorean theorem. Makes this stuff fairly easy to figure out. Because when I go down here, and I'm given the point negative 2, 3, and that's on the terminal side of whatever the angle is. So when they say terminal side, that's in contrast to you have your initial ray over here and your terminal side over here. Negative 2, 3 is on that line somewhere. Obviously not to scale. And theta is your angle there. Well, if I want to figure out sine, cosine, and tangent for that, well, I need to know the r value. So how would I find the r value given those two? Yeah, just use the Pythagorean theorem. Literally, take your x distance, which is negative 2 in this case, squared, plus the y distance, which is 3, squared, then square root the whole thing. That's your r. What do you get for r then? Square root of 13. Okay? So then when I go to do sine, sine of theta is just going to be equal to the y value over the r value. In other words, 3 over the square root of 13. Can I leave my answer that way? Nope. What does it turn into? Yeah, 3 root 13 over 13. Cosine of theta. What will the final form of that one be? Negative 2 root 13. Just negative 2 root 13? Over 13. And tangent ends up being the easiest one because the 13s, or the square root of 13s, the denominators essentially just cancel each other out when you multiply by the reciprocal. All you're left with is y over x. In this case, that would give you the square root of 13s go away entirely. Yep, 3 over negative 2 or negative 3 halves.
Oh, yeah.
Okay, because if you take y over x, in other words, sine over cosine, y over r times r over x, the r's go away, you're left with y over x. So the nice thing with tangent, you can just actually jump straight to that if you're given the coordinate. Okay? Now, the only thing you really need to keep track of for a lot of this stuff is which quadrant you're dealing with has what ramifications for the sign on the trig function. Okay? Because if you're, depending whether you're looking at first, second, third, or fourth, well, the signs change here. Okay? However you want to get memorized which are where, go ahead and do it. One way is if I actually just label this, all students take calc, going around it. All trig functions are positive in this quadrant. Only sine is positive in the second quadrant. Only tangent in the third quadrant. And only cosine in the fourth. Okay? One way to memorize it, I don't care how you do it. So when I go down to a problem like this, I can actually figure out which quadrant it's talking about. Because sine theta equals 4/5, that only tells me what about the quadrant? Yeah, it's either 1 or 2. It's in the upper half. Tangent of theta being less than 0 narrows it down to which quadrant? Quadrant 2. So the idea is this 4/5 here is going to be somewhere over here. 4/5 is fairly close to 1, so that tells me it's going to be about there. Ballpark, not exact. I want to find cosine. How could I go about finding cosine? You could do sine squared plus cosine squared equals 1. That uses identities. The other thing you're actually able to do is cheat a little bit. Because I'm just looking for these values, I don't actually care where they fall. Okay, what circle they're on. So I can actually relabel this a little bit. Because sine, if I generalize that out to a right triangle, so if I draw this same angle and drop the vertical down, this theta is going to actually be the angle right here. Okay? So, sine in general is what over what? Opposite. So the opposite of theta would be what? 4. And where on here would that be? Yeah, that vertical line. So 4 would be here. Where's the 5 at? The hypotenuse. So then what's this side have to be? 3. 3, 4, 5 triangle. You may know what that's called when you have like 3, 4, 5, 5, 12, 13. Not quite. Nobody remembers?
Why should it be?
Because I told them last year what it was.
Oh,
You not necessarily, but I know I told them last year.
Like 30, 60, 90.
Not quite. Those are special right triangles. 30, 60, 90, and 45, 90 are special right triangles. This is what's called a Pythagorean triple.
Yeah.
Okay?
Whoa.
There's a bunch of them out there. They show up on tests constantly. The ACTs will use those numbers constantly. If you're comfortable with them, and honestly the AP Calc test will probably use Pythagorean triples, because they come out to an exact number. They don't have a decimal. They're not the square root of something. They're just integers. That's why it's good to know at minimum 3, 4, 5. And if 3, 4, 5 works, that means 6, 8, 10 works. Any multiple thereof. The 5, 12, 13 is another common one. There's quite a few others. Okay. Anyway, going from this, what would cosine of theta be? 3/5. Except for that's wrong. Why negative? It's in quadrant 2. Cosine is negative in the second quadrant. Cosecant would be what?
1/3.
What would it be? 5/4. Cosecant is the reciprocal of sine. So since sine is 4/5, this would be 5/4. And cosecant takes its positive or negative from sine. Secant takes it from cosine. Cotangent takes it from tangent. Questions so far? Okay. What if I have this? Cosecant and cotangent, find those values for 0, pi over 2, pi, and 3 pi over 2. Okay? And the nice thing about cotangent and cosecant, they are both those types of reciprocal identities, right? Cosecant is what over what? 1 over sine. Cotangent is what? 1 over tangent, but you also have an alternate that you can use for that one.
Cosine over sine.
Cosine over sine. What do these have in common?
Sine of drawing.
Sine is on the bottom. So, if I look at these, a big part of what these are going to be is dependent on what sine is. Because sine can't be what? 0. Well, the question becomes, of these 4 things, where is sine 0?
0.
That's 0 and pi. Right here, at these 2 values, you get 0 for sine. And since this is divided by sine, what's going to be cosecant of 0? Undefined. That's the word for it. Okay? I mean, you could also do that empty set thing, same idea. Solution does not exist. Then for cotangent, when you do that one, it's going to have the same exact undefined parts. Now, it's going to behave slightly differently when I'm looking at the other 2, though. So these are going to be undefined here and here. What about cosecant of pi over 2? Well, what's sine of pi over 2? 1. So then what's cosecant of pi over 2 going to be? Reciprocal of 1 is 1. Cosecant of 3 pi over 2?
Negative 1.
Negative 1, because the sign is also negative 1. When you do cotangent of pi over 2, though, what are you going to get? 0, because sine is still 1, but cosine is 0. 0 over 1 is 0. And cotangent of 3 pi over 2? 0 as well. Because again, 0 just now over negative 1 is still 0. Okay. Reference angles. Now, this is a way to think of it, and this is honestly the way I think of it to remember values generated on the unit circle wherever they're at. I always refer back mentally to where they are in the first quadrant. And that's what reference angles are talking about, essentially. The idea for a reference angle is theta can be any angle as long as it's in standard position. The reference angle for it is the theta value that's formed by taking the terminal side where it stops and going straight to the horizontal axis. Okay? What that looks like, what that translates to, is if I have this situation. So if I'm in the second quadrant and the original angle is here, the book will use theta prime for the reference angle. It's going to drop to the x-axis. If you're in the third quadrant, it'll rise to the x-axis there. If you're in the fourth, it'll do the same thing. Okay? And the reason you do that is because then it allows you to figure out, based on the first quadrant, which the nice thing there is everything's positive, and then you can just use that. Okay? For this one, reference angle of 213. Well, 213 is in which quadrant? Third quadrant. So it's over here somewhere. So the reference angle is going to go from there straight to the x-axis. Well, if this is 213, how would I find that angle there? Subtract 180. 213 minus 180 degrees gives you what? 33. So what that's saying is this small angle here is just 33 degrees. But it's going to have the same trig properties that the 213 does for sine, cosine, tangent. Those ratios will still be the same, adjusted for quadrant. 1 pi over 7, what quadrant's 1.7 going to be in? Third?
Yeah.
Why?
It's greater than 1. Less than 2. I don't know, I'm taking guesses right now.
Okay. Why would it be 2?
Oh, because it's greater than 1.5.
Yeah, pi over here is 3.14. It's in radians because it doesn't say degrees. So this is 3.14. Pi over 2 is 1.57. So 1.7 is going to be somewhere over here. Because we're in the second quadrant, I want to the reference angle. Make sure, do not take it to the y-axis. It always drops or rises to the x. What would I do to find that value? Yeah, the idea is this theta value that they're giving you here, that's the measure from here to here. If I want to figure out from here to here, I'm going to take the 180 or the pi minus whatever that angle is as appropriate. What's pi minus 1.7 going to give you? Or 3.14 minus 1.7 if you prefer. 1.44. 1.44 radians. And oftentimes you will be given pi, but it's trying to get you used to seeing that radians without having the pi there. 144 degrees is which quadrant? Second. So you're going to do what to find the reference angle? 180 minus 144, leaving you with 36. Yep. Okay. Now once you have those reference angles, what you can do with them, especially if they're ones that are actually on the unit circle, is, if I just turn the page right away, presentate. The process for this, honestly, all this is find that reference angle value and then adjust it by quadrant. Using that whole all students take calc thing or whatever method, make sure you just switch it, because when you do the reference angle, it's going to break it down to the first quadrant. So that allows you to then just have a few basic parts of the unit circle memorized and then be able to adapt from there. Okay? Now they list everything on here, honestly. The cardinal directions I would kind of expect you to know. The 30, 45, 60 values, you should be close to getting those memorized. If not, get them there. Okay? So, what I can do with that then is if I have something like the sine of 5 pi over 3, and this is where radians are very, very nice. Because the reference angle for this, well, which quadrant first off is 5 pi over 3 in?
Second.
Which quadrant?
Second.
Fourth. The way to remember that kind of thing, 2 pi is here, right? Well, if I do 2 pi is here, well, if it's over 3, this is 3 pi over 3, this is 6 pi over 3. 5 pi over 3 then would be right about here. Okay? Now the reference angle for radians, I would take 2 pi or 6 pi over 3 minus that 5 pi over 3, leaving you with what? Pi over 3. Your reference angle here, this is equal to this up here. For reference wise. I probably shouldn't do theta for that, but you get the idea. For that then, I can treat this, and this will work for any of these radians that are on the unit circle. All you got to do is look at that part of it. 5 pi over 3, 4 pi over 3, 2 pi over 3, all have a reference angle of pi over 3. 7 pi over 6, 5 pi over 6, 11 pi over 6, all go to pi over 6. Pi over 4 does the same thing. So you can always refer back just looking at that part. You don't actually have to do much with it. So for that then, I'm just going to think of pi over 3. At pi over 3, what's sine?
6.
Well, pi over 3 is the same as 60, but what's the actual sine value there? Square root of 3 over 2. Okay? Now the question becomes, when I change it to sine of 5 pi over 3, what's that going to do to the square root of 3 over 2? Make it negative. Because you're in the lower half of the graph, so sine is negative there. Cosine of negative 60. For cosine of negative 60, again, you're down in the fourth quadrant. So what's your reference angle going to be? 60 degrees. What's cosine of 60 degrees? Is cosine of 60? Yeah, tip. The reference angles will always be positive, and then you adjust after that. Now you're in the fourth quadrant, so what happens to the 1/2?
Stays constant.
Stays the same. Cosine of negative 60. Cosine in the right half of the graph remains with whatever sign it currently has. Tangent 11 pi over 6. Where's 11 pi over 6 at?
Fourth quadrant.
Fourth quadrant. Fairly close to the x-axis. So for this one, I want to cheat a little bit. I'm going to use sine and cosine. What's the reference angle? Pi over 6. So what's sine of pi over 6? One half. And I'm going to change the format of this a little bit. Instead of dividing 1/2 by the cosine, I'm going to multiply by its reciprocal. What's cosine of pi over 6? Square root of 3 over 2. So then when I multiply by its reciprocal, I'm going to multiply by 2 over the square root of 3. 2's go away. 1 over the square root of 3 simplifies to what? Square root of 3 over 3. So my answer is square root of 3 over 3. Why? Because it's in the fourth quadrant, and tangent in the fourth quadrant is negative. Questions so far? All right. Theta. Let theta be an angle in quadrant 3 such that sine of theta is equal to negative 5/13. Find secant of theta and tangent of theta by using trig identities. It's almost the same as the problem we did earlier. The problem is it does say using trig identities. So I can't draw the right triangle and do it that way, setting up the 5 and the 13. Instead, I need to use which identity?
It's sine squared. It's cosine squared.
Yep, sine squared plus cosine squared equals 1. That's your Pythagorean identity. So sine squared plus cosine squared is equal to 1. Plug in. Negative 5/13. If I square that, I'm going to get what? Without the calculator. 25 over 169 plus cosine squared equals 1. Subtract the 25 over 169 from both sides. You're going to get what? Essentially 169 minus over 169 minus that 25 over 169. 144 over 169. Because the nice thing is this is another Pythagorean triple. When I square root the top and the bottom, I'm going to get what? 12/13. But what quadrant are we in?
Third.
So that cosine should actually be
Negative.
negative. Yep. Now it's not actually asking for cosine, but I needed to figure out the rest of it because secant theta is going to be what? Say that again. You can do 1 over cosine, but what that means is it's reciprocal. So all I have to do is take negative 12/13 and flip it. Negative 13/12. Tangent of theta. Tangent again is sine over cosine. So, what would I put first?
5. Negative 5 over 13.
Negative 5 over 13. Now I want to multiply that times
13 over negative 12.
13 over negative 12. What goes away?
13's in the negatives.
Leaving you with
5 over 12.
5/12. It's not too bad overall, but you'd be surprised the number of negative signs students will miss on the next quiz. All right. One last thing. Probably not. Go ahead and find these three values.
I bet you can do it without a calculator, right? Why are you using a calculator, Russ? Why are you still using a calculator? Did you try doing it without a calculator?
Who's cosine? But sine, cosine, yeah, I'm not doing that one.
Wait. Cotangent. What do you want? I'm confused.
What's cotangent? 375. Anybody? Anybody else get that? Okay. What about sine negative 4.1? 0.818? What about secant of 3 pi over 8? Did anybody not get those? Okay. That's honestly it for 4. Monday I'll go over any questions as far as the quiz and stuff goes. You'll also have time to work. Tuesday we'll look at 4-5. Wednesday's the quiz over 4-1 through 4-4. The rest of the time is yours.